So we're still talking about polynomials, and today we're going to talk about a theorem. It's actually two theorems that we're going to combine into one. I know you guys probably don't ever look at your books, but section 4.2 has tons of theorems in it, which are always fun, math theorems. Like think back to geometry. So there's lots of math theorems in this one, and we're going to combine these two together into one theorem, make it a little simpler. All right, so the factor slash remainder theorems, just kind of can smush them together. We talked about factored form yesterday, so it's going to be using a factor, and basically we're going to take a polynomial function. Theorem says if we take a polynomial function and we divide it by a factor, and when we divide it, we get a remainder of 0. So if you've never seen synthetic division before, this might be a little bit new. But if you have, then it's basically just synthetic division. So we're going to take a polynomial, we're going to divide it by a factor, and if we get a remainder of 0, that tells us that that factor that is a factor of the function. It'll make a little more sense when we look at an example, obviously. But if we take a function, we can just make one up here. Let's say a function 3x cubed minus 4x squared plus 10. And if I were to divide this function by a factor, say x minus 2, if I divided it and I got a remainder of 0, that would mean that this is a factor of that. In addition, if this is a factor of the function, then we can also say that whatever that number is, in this case 2, would be a 0 of the function as well. So that factor is a factor of the function, and then the number, we call c, is a 0 of the function. And the way that we're going to figure this out, we're not going to do long division, we're going to do something called synthetic division. So we're going to accomplish using synthetic division. Anybody familiar with synthetic division? Yeah? Anybody else? Do you remember it, Emily? It's like the box thing with the numbers.
Oh, like, oh god.
I think so.
We never called it synthetic division. We really just called it synthetic.
Box method?
Yeah, we always call it.
For division? It's not factoring. It's not factoring.
Oh,
Not factoring.
Well, when you say box with number, it's kind of vague. That's
Alright, I'll show you.
that's what I was thinking.
exactly.
It's like box method, right?
But never mind. I have no idea.
It's not hard. Isn't it? I promise. This isn't hard. Alright, let's go ahead and try our first example. I wouldn't write out the directions. They're long. Alright, so we've got our function. Just so I can write that down. And what we're going to try to do is determine if x minus 2 is a factor of that function. Okay, which would also tell us if 2 is a 0 of the function or not. There's different ways you can do this, but I want you to do synthetic division. You need to know how to do that. I want you to do it. So here's how it works. We're going to take these numbers, and we're just going to write them out with a little bit of spacing. 4, -3, -8, 4. And then I'm going to draw this kind of this half box, leaving some space in. Does anybody know what number goes outside the box? So it's close. It's going to actually be positive 2. So it's like if you were to set this equal to 0 and solve it, then you would get x equals 2. So it's just the opposite. We're going to write 2 out here. You've probably seen it before. If not, like I said, it's not a big deal. Well, then what we're going to do is bring the first number straight down. So we're just going to drop it down and write it right here. We're then going to multiply the number on the outside times the bottom number. So we did 2 times 4, that's 8, and we're going to write it underneath the next number. We're then going to add these two numbers together. Add them together, negative 3 plus 8 is 5, so we write it down here. And then we're going to do that again. We're now going to do 2 times 5, which is 10. We're going to write 10 over the next one. And we're going to add them together. Negative 8 plus 10 is 2. Do it again. 2 times 2 is 4. Add them together. Where we get 8. So we got all these numbers. The only number that we actually care about, at least for right now, is this one. This is the remainder. The last number is the remainder. So that's the only number that we're going to look at. These other numbers are important, just not for what we're doing right now, but they are important. And the theorem says that if we get a remainder of 0, then it's a factor, and then also that number is a 0. We did not get a remainder of 0, so this was not a factor. It was not a factor. So we just say x minus 2 is not a factor. If we had gotten 0 for the last one, it would be a factor. It's also saying that 2 is not a 0. 2 is not a 0. I can say both of those things. Now there is extra stuff you can do with this. You can then take what's left over and then do some more stuff. But for today, that's what we're going to stop at. Let's try another one. So there's our function. Before you write your box out, I want to point something out to you. So there's one thing you have to be careful with. If you notice our exponents, it goes 4, 3, but there's no 2, there's no second power there, right? So you actually have to do this. You have to put sort of an imaginary second power in there, so that when we write it out, we're going to have to put like a placeholder of 0. Just think of it as a placeholder. So there's like 0x squares. You don't have to write it, but it'll help you remember when you write it out. You do that. So we have 3, now we have 2, 1, and then none. So 0. So when we write these out, we're going to do 3, negative 6, just make sure you keep the signs, 0, negative 5, and 10. If you don't put that placeholder in, it'll give you a different answer. You got to put that placeholder in. Okay. But then draw our little half box here. And what number goes on the outside? 2. Right. Positive 2. And maybe take a second and see if you can figure out the pattern. Alright, so bring the 3 down. 2 times 3 is 6. Add them, you get 0. 2 times 0 is 0. Add them, you get 0. 2 times 0 is 0. Add them, negative 5. 2 times negative 5 is negative 10. Add them, you get 0. So since we got 0 as our last thing, our remainder, we can then say yes, x minus 2 is a factor. And you could also say and 2 is a 0. These other numbers are meaningful, like I said, but we don't need to worry about them for today, but they are meaningful. Try a couple more. Now this one you really have to be careful because it goes a 6th power to a 3rd power. See if you can maybe write out your box. Don't solve it just yet, but see if you can write out, fill in all your placeholder zeros. About where all the places you would need them. So you gotta put 4 placeholder zeros in. Gotta have 0x to the 5th, 0x to the 4th, 0x squared into 0x. It's kind of long, but it still works. Go ahead and give it a shot. So you should get a 0 as your remainder again. You can check your work here. Drop the 3, multiply, negative 9, add it, 9.7. Okay. Just make sure you take your time on the operations. One mistake messes up your whole answer. I got one more for you to try. And this one else, just do it all on your own. So you just count it down. So you start with a 6. You have a 5th power. Nope. So it's like a 0x to the 5th. have a fourth. You have a third power.
Oh, okay. I see.
Yeah, so no third, so 0x cubed. You do have a second power. You don't have a first power, so 0x. So you gotta put 3 in there. There's no number for the next 30 unit, which is 1. Should be a no. This one is the remainder of 1. We're getting it? Yeah, really just gotta make sure you do your mental math well. If you need to use a calculator, do it. Just make sure you do it right. Got one more fraction. Finish it off here. This one, you only need one placeholder. Alright, this one is a yes as well. You do get 0.